Hi everybody. Today we're going to take a look at something new in the world of moles, and that is how to convert from moles to mass, and then go from how to convert from mass to moles to number of particles, or vice versa. So we've already looked at this part pretty carefully. We've converted from moles to particles and from particles to moles, so this part will be old hat, and this will be new. But if you could do this part, you can do this part. It's just as easy. Just a little bit different steps. So our two objectives are to be able to first convert between mass and moles to mass, that way. And then the second objective is to go all the way from number of particles to mass, or from mass to number of particles. So you could say, if I have 55 grams of gold, how many particles are in that gold? So in that case, we'll go from mass to moles to particles. So there are going to be two-step equations here in just a little while, two conversion factors. All right, so first we'll start off with just moles to mass. You have to have your periodic table with you, or be able to see one right now, and then and you need a calculator, and then we'll figure this out. All right. A typical problem might say something like this. You have 319.6 grams of silver. How many moles is that? All right, so you write down what you know, 319.6 grams of silver. And then way over here you write an equal sign and how many moles. So I want to know how many moles. All right. Well, I want to get rid of grams and I want to get moles. And doesn't that look a lot like what we did with number of particles? The difference is, this information, moles to grams and grams to moles, you have to get this information from the periodic table. It's different for every different element and every different compound. So you can't just memorize 6.02 times 10 to the 23rd. Nope, you have to look it up. Well, let's go ahead and do that. We're looking up silver right now. Look on your periodic table and it says 107. 107.7, so let's go with 108, I should have said. 108 grams per mole. 108 grams per mole. 1 mole weighs 108 grams. So let's look. Where do we fill in the 108? 108 grams per 1 mole. Okay? Grams will cancel with grams, and then you just do your math like we did in previous days. All right, so we turn it on and hit clear. It's 319 times 1, if you want to multiply by 1, and then divided by 108. The answer is 2.95. So it's 2.95 moles. That's our answer. Let's try a problem in which we go from moles to grams. So you're in the lab or you're reading a question or something and you figure out, well, what do I know? Oh, here it is, 1.73 moles. So you just write that down. Whoops. I'm not doing well. Let's try this again. 1.73 moles. Way over here, write down an equal sign, and then what do you want to get? Grams. So you put in a conversion factor, and you say, I want to get rid of moles, and I want to get grams. And L goes down here, G goes there. All you have to know is, where do you get this grams to moles and moles to grams information from? In the periodic table. Now this is Br2. That means you have a let me write it up here, a bromine atom bonded to another bromine atom. So if you look at the periodic table, it says that this one weighs 80, but this one weighs 80 also. Together, the whole thing weighs 160. Next thing, say to yourself, 160 grams per mole. And then you got this equation licked. 160. 160 grams per 1 mole. 1.73 times 160 divided by 1. And your answer is going to be something approaching 300. Go ahead and calculate it. If you get pretty close to 300, you know you did it right. This problem here, you're given moles and you want to get grams. So it's just like this one in red, except for NABR is our compound. And so you have to look at the periodic table, and instead of 160, we're going to have a different number. Na weighs 23, Br weighs 80, together that's 103. So this number would be 103 grams per mole. So you'd write down 3.0 moles way over here, equal sign, grams. I think we said we want to get rid of moles. Get grams. It's 103 grams per mole. There you go. Next problem is just the same kind of problem. It's the same as this first type, but I threw in 1.2 times 10 to the negative third, so a small amount of grams. So this would be 0.001 grams, 0.0012 grams. It would be a small amount, like just a little dusting of stuff. All right, that's the first objective. We've got this. Second objective is, how do we go from particles to moles to grams, or from grams to moles to particles? All of these problems will require two factor label method conversion factors. Right? So what do you need to know here? You need to know these two bits of information. 1 mole is always 6.02 times 10 to the 23rd particles, but 1 mole has a different number of grams depending on the compound, like we just did. All right. So let's look at this first problem. We're given 3.1 times 10 to the 21st atoms. And it says, how many grams is that? Well, atoms is a type of particle, and we want to have this for an answer. We're going to need 2 steps. So let's just go ahead and put in 2 conversion factors. And way over here, write down equals grams. All right, get rid of atoms. And what can we convert atoms to? Atoms is a type of particle. We can directly convert it to moles. So atoms will cancel with atoms, and then we'll have moles. But that's not what we want for an answer. We want grams. So now we have to get rid of moles and get grams. Right? It's just a matter of plugging in our numbers and then doing the math. I'll use a different color. All right, moles to atoms. Moles to atoms, moles to particles, that's 6.02 times 10 to the 23rd. 1 mole is 6.02 times 10 to the 23rd atoms. Next, grams to moles information. You get it from the periodic table. Carbon atoms. Look at the periodic table, it says 12. 12 grams per mole. So let's plug in 12 grams per 1 mole. Okay? And let's start doing our math. Atoms cancel with atoms, moles cancel with moles. Answer, what survives is grams. So let's do the math. Let's see. 3.1 second EE21 times 1 divided by 6.02 times 10 to the 23rd equals, times the top, times 12. The answer is, calculator's not working so well today. The answer is going to be something like 0.5 times 12, 5 times 10 to the second, 0.05. Should be 0.05 grams, really close to 0.05 grams. Go ahead and calculate it. If you don't get close to 0.05 grams, you've got a problem. Let's try this right now. Right. Okay, so 4.01 grams is what we know. 4.01 grams. I want to get atoms. So way over here, right, I'm going to write down atoms. Now let's pretend we didn't know that we do need 2 conversion factors. We would think to ourselves, grams, grams, grams. To go from grams to atoms, that's a type of particle, it's 2 steps. So I will indeed need 2 conversion factors. The first one, I want to get rid of grams, and I want to get moles. So I thought MOL. And the second one, I want to get rid of moles and go right to particles. So moles to particles. In this case, what kind of particles are they? They're atoms. All right? Grams to moles information from the periodic table. Moles to number of atoms, 6.02 times 10 to the 23rd. Okay, so we're talking carbon atoms. They weigh 12. 12 grams per mole. 12 grams on the bottom this time, 1 mole on the top. And then over here, moles to atoms. 1 mole is how many atoms? 6.02 times 10 to the 23rd atoms. All right, I've got my good calculator, so I'm ready to go. 4.01 times 1, hit enter, divided by 12, hit enter, multiply by 6.02 EE23, hit enter, divide by 1 if you wish, and our answer should be, let's write this in green, 2 times 10 to the 23rd. 2 times 10 to the 23rd atoms. We'll work on how many, how to round this off later on. And then we've got 2 more problems here, one in which we go from grams to formula units. That's just like this previous one. The only thing you have to look out for is, what's the mass of NaCl? It's 23 plus 35 is 58. So, otherwise it's the same as the second problem. And then right here we have 3.45 times 10 to the 19th carbon dioxide molecules is how many grams. So this problem will be just like this first one. And you have to be careful because CO2 weighs 44, I think it is. No, let's see, it's 16 plus 16 is 32 plus 12 is, yeah, it's 44. 44 grams per mole. Well, this is going to take a little bit of time to, become an expert, but let's take a quick look at what we did today. All right, so this is moles lesson 4, mass to moles to number of particles. There's 2 objectives. Just, figure out how to do mass to moles and moles to mass, because we've already done moles to number of particles. And then the second part is going all the way 2 steps from mass to moles to particles, or from particles to moles to mass. And so the first thing we did was we set up 1 conversion factor problems, grams to moles, and then somewhere here we should have moles, yep, right here, moles to grams, and we use this information from the periodic table. And then the second thing that we did was using 2 conversion factors, in which one of them, we used 1 mole being equal to 6.02 times 10 to the 23rd particles, and the other conversion factor using 1 mole is equal to so many grams, and that you get from the periodic table. So, we'll work at this, and you'll become experts before too long. Thanks.